All right. Finally, for operations with rational expressions, we need to look at adding or subtracting, and this is a subtraction, when the denominators are not the same. So we're going to have to actually find a common denominator here. First, we have to factor anything that's not factored. The x minus 4 is already factored. We'll just put parentheses around it. 2x is already factored. 2 is already factored. But this down here, 2x plus 4, can be factored. There is a GCF of 2. So I'm going to pull out a 2 and write x plus 2. So let me just rewrite that so it's a little cleaner. I have x minus 4 over 2x plus 2 minus 2x over 2. Now, my common denominator. It has to include both denominators. So, if I look at the first one, I have 2 times x plus 2. So my common denominator has to include that. Then, if I look at my other denominator, I just see that I have a 2. Now, if I didn't already have a 2 in this common denominator, I would have to add it now. Well, multiply it, include it in here. But I do. This denominator, this common denominator, includes both factors of the first denominator and includes the entire second denominator. They're both included in that common denominator. So we have a common denominator. We can go ahead and get the domain restrictions from this. Of course, 2 not equal to 0 doesn't give us anything. But we also have x plus 2 not equal to 0, which gives us x not equal to negative 2. So that's actually our domain restriction, and we can get that right away. We can also then go back up here, and we have to make sure that anything that's missing in either of the denominators gets multiplied in. So I look at my first fraction, and this denominator, 2 times x plus 2, is exactly equal to 2 times x plus 2 here in the common denominator. So this one is fine. I don't have to do anything to that. But if I look at this second denominator, I just have a 2. I need to have a 2 times x plus 2. So I'm missing something there. I'm missing that other x plus 2. So I'm going to put that in here. I have to multiply it. It's x plus 2, like so. Now my denominator matches my common denominator. But, of course, equations and fractions, anything like that, you have to think about balance. If I do something to one side of an equation, I have to do it to the other. If I do something to one part of a fraction, I have to do it to the other part, or I change the value, and I can't do that. So I have to actually multiply this top and bottom, numerator and denominator, by that missing factor. Okay? All right, so got kind of a mess up here, but I now have a common denominator. So my denominator is just going to be 2x plus 2. On top, I have x minus 4. And now, since the denominators are the same, I can go ahead and combine this numerator. So I have x minus 4 minus 2x times x plus 2. Now, I will need to take this negative 2x and distribute it into the second factor. So let's look just at the numerator for a minute. Let's pull this out to do some work on that. So I have x minus 4. The parentheses don't really add anything. And then I'm going to have minus 2x times x. That's 2x squared. And negative 2x times 2 gives me minus 4x. I can simplify this a little bit, put it in standard order. So I've got my quadratic term, negative 2x squared. I have x minus 4x. So that's minus 3x. And I have minus 4. Okay, so that's my numerator. But I already have my denominator. That's just 2x plus 2. All right. This 2 isn't going to simplify out because I have an odd number right here that's not divisible by 2, so I don't think I have any way to simplify this. X plus 2 is not a factor of this numerator, so we're going to go ahead and call this our answer. It doesn't simplify, and we've got it. And of course, we already have our domain restriction. We got that earlier.